Hello everyone, welcome back to the channel. My name is Matthew Sanabria, and in this video, we're going to talk about SSH host keys. Now, the other day, GitHub published this blog post saying that they rotated their RSA SSH host key. And if you are a developer that uses RSA SSH keys with GitHub, you may have seen an error like this or a warning when connecting to GitHub to do a clone or to do a push or whatever it may be. Now, perhaps you froze for a second and you're like, wait, what's going on? What's like, maybe you got scared. I don't know, right? Maybe you didn't know what was happening. And perhaps you went to Hacker News or Stack Overflow or Slack, or you heard from a friend and they pointed you in a direction of this blog post, and you were able to follow the directions here and figure out how to fix this, right? But this video is about, I want to take a time in this video to talk about what these SSH host keys are and like kind of what happened here, what happened under the hood, so that you as an engineer can better understand the tools that you're using and know like how they work. And so when things go wrong, you can better debug them, right? So briefly, SSH authentication or SSH key pairs are just a way to authenticate to a given server. So in GitHub, you're allowed to use SSH to clone and interact with repos instead of using HTTP. You can also use SSH to connect to your Linux machines or your servers instead of going in through like a terminal connected to it, right? So SSH key pairs, they're basically what we call PKI or public key infrastructure. There's a private key and a public key. And the private key is a key that you hold on to because it's secret. And the public key is a key that you give to the service that you want to connect to. In this case, it could be GitHub, right? And those private and public keys are cryptographically linked such that they can be used to encrypt and decrypt data together, right? I encrypt with my private key, and you can decrypt with my public key, right? It's a way of exchanging information. Now, that public key and private key pair, they can come in many types. One type is RSA, another type is ECDSA, another type is ED25519. Now, you can go read about those different types if you want. RSA has been a popular type for a long time. ED25519 is a newer type that's more people are starting to move to because it's pretty, it's more secure. But for those that are using RSA keys with GitHub, they would have seen this warning when GitHub rotated their RSA host key. Now, what is an RSA host key? What's a SSH host key in general? Well, SSH host key is just a key that gets presented when you connect to an SSH host for the first time, or technically every time, but the first time is the most important time because it prompts you. So basically that SSH host key is just saying, I'm this person, I'm this host, right? So if you were to connect to a different host later on and their host key was different, it would warn you and say, hey, this host has changed. It's not the same host key that I remember. Let's see what that looks like in practice. So I have a machine out on the internet and I'm going to connect to it via SSH, and it's just called sudomateo.dev. And since this is the first time I'm connecting to this host, it's saying, hey, you're trying to connect to sudomateo.dev at this IP address. You've never connected here before. Do you want to continue connecting and trust this host key? Now you'll notice it printed out the fingerprint for the host key, and the host key type that it gave me was ED25519. That is because I have previously uploaded my ED25519 public key to this server, much like I would to GitHub, and I held on to my ED25519 private key. So I'm using an ED25519 key pair to connect to this server. So it gave me the ED25519 host key. So it's saying, hey, this is the host key for the host you're about to connect to. Is this okay? Since you've never connected to it before, I'm going to prompt you and just make sure that this is what you want to do. I'm going to say yes because I know this server. This is my server that I just spun up. I'll say yes. It'll now add this line right here. It'll now add that host key to my known hosts and go ahead and connect. So I'm going to disconnect from this host for a second, and I'm going to print out the my known host file and show you those keys that it just added to my known host. So you'll notice here it added 3 keys, an ED25519, an RSA, and an ECDSA key. Even though I connected using an ED25519 key pair, it added all of the host keys for that host that it knows about or that it knows how to speak. just in case I want to use a different key in the future. It doesn't have to reprompt me, right? Because these host keys were there at the time that I chose to trust it. So at this point in time, I have these three host keys that are trusted for this host. So let's reconnect to the server, drop down to the root user. And what I'm going to do next is I'm going to simulate what GitHub did, right? They rotated their host key just for the RSA, right, type. So they just rotated the RSA host key type. And that means everyone that was using an RSA key pair to connect to the GitHub had to go retrust that now. So I'm going to simulate that action by rotating all of my host keys, right? On a typical Linux machine, the host keys are in RSA SSH, and they're with files that start with SSH_host. You'll see there's public and private keys for each type, right? DSA, ECDSA, ED25519, etc., etc. I'm going to go ahead and remove all of them. So remove RSA SSH, SSH host star, and they're all gone. And now I'm going to regenerate them using SSH keygen -A. It's going to generate all new host keys. And now you'll see that they are all there again. And I should have showed you the timestamps, but I'll just do it one more time real quick. Remove them, ls etc ssh. They're not here anymore. Regen them. And I will ls again, and now they're back, right? So I just rotated them out. And this is what GitHub did, but they only did it for the RSA key type, right? So let me disconnect from this host now and go back to my local host, and I'll try to reconnect to this SSH host, right? Or if you were the GitHub user, you would try to clone a new repo or push commits to a repo, and you'd get something like this, right? Warning, this remote host has changed. Something's going on. I need to catch the user's attention. I'm going to put, @ symbols everywhere. I need to catch your attention. It wants you to know that, hey, I'm trying to connect to sudomateo.dev, and its host key is different than what I previously trusted. So now it's failing. It's choosing not to connect because it doesn't know if this is a man-in-the-middle attack or what's going on. It doesn't want you to be in a weird way where you connect to a host that you never really trusted, right? A man-in-the-middle or such other things. So me as the engineer, I have to go fix this. And if you read the documentation here, if you read these logs, it kind of tells you what to do, right? It says, please contact your system admin, which is you, right? You're an engineer. And it says to add the correct host key in the file and blah, blah, blah. So basically what it's saying is you need to update the host key in your known host file to trust the new key. And what I'm going to do instead here is I'm actually going to edit the SSH known host file. And you see these three keys that I trusted before. Well, since I rotated all of the keys on my server, I'm just going to go ahead and get rid of all of these, right? Now you can bring the keys in and trust them, but for the sake of this example, I'm just going to remove all of the keys in here just because I only have those three keys. Save that file and then go connect again. And you'll notice this time it's as if I never connected to this host before, and it'll prompt me if I want to trust this key. I could have chosen to just import this key myself using an SSH command, but instead I just chose to remove the keys that were like the offending keys, reconnect, and have it prompt me one more time. And you'll see that this is the key. I can say YES, and now I'm back in, right? So that's what happened with GitHub the other day. They just rotated their RSA SSH key, and anyone who was using RSA needed to just trust that new key. And their blog post did a wonderful job covering what you needed to do to get working again. But a lot of people froze, right? And a lot of engineers didn't know what to do. And that's what prompted me to make this video in the first place after my long day of manual labor is I wanted to get this information into the hands of you, the engineers. Because as an engineer, part of being a great engineer is knowing your tools and knowing how to use them and how to be successful with them. So when things like this go wrong, you don't just freeze and sit there like, what do I do? You have an understanding of what's going on, you can debug it, and you're a better engineer because of it. And also, like, I just want to give you some context as to what's going on under the hood. It's nice to just kind of peel back the layers sometimes and see like, oh, that's what they mean. That's how it works. That's what they're used for. So I really hope that you all found this video helpful. I really want to help engineers not only be better engineers by coding and writing, but understanding the tools that they work with every single day. So if you found this video helpful, please let me know. And if you're still using RSA SSH key pairs and you want to swap to ED25519 and you have no idea how to do that, leave a comment below. I might create a video about that as well. But again, thank you all for watching this video, and I will see you in the next one.